There we go. Alrighty, folks, welcome to Thursday, the 10th of September, our fourth lecture together. Remember, we have our lab this afternoon, and compared to the previous, all the years I've been teaching at LMU, we don't start at 1:05 today, we start at 1:30, which gives more time between classes when we're finally back on campus. Does anyone have any reflections they'd like to share today? Something interesting happening in your neck of the woods? Wherever that neck might be, maybe in Denmark.
I woke up yesterday morning. I'm in like the East Bay, and like the sky was completely orange because of the fires and smoke. And like I go outside like to take out the trash, and like everything's covered in like ash and soot. It's like crazy.
Yeah, it's pretty extraordinary. We're going to talk about that in just a moment because I've only been in California for 10 years, and this is the most amount of acreage that's ever been burning at one time since I've been here. It's 1 million acres, the size of Massachusetts. Um, just staggering. 43 fires. And we'll talk a little bit about what the conflagration of ecological variables are that brought this on, because we're only at the beginning of the fire season. That's what's so scary. Anybody else? Okay, so let's share the screen for a moment here. And we have to make sure we set up our groups today. So as you know, I sent you all the sign-up sheet to kind of check out and think about what group you might like to be in and that kind of thing. So if by 9 o'clock I haven't brought it up, please somebody mention it, or I'll just, be into the whole lecture thing and we'll just be, gliding along, and all of a sudden, boom, we're at the end again. Um, okay, let's share the screen. Let's do desktop. And I'll close this down just a little because I still like to see everyone. Okay, so this opening image is pretty disturbing. This is Southern California. As I said, we have almost 1 million acres in flame right now as a result of a variety of ecological factors. And so something like 97% of all Californians right now are breathing air that is considered very poor quality because of the ash and other irritants and chemicals that are released during these kinds of fires. So here are some data taking a look at fires in California right now. And you can see the running 5-year average. And going back to 1990, and you can see, with the exception of a couple of years ago where we actually had a bunch of rain, we're seeing this steady rise in the acres burned in an average year. And here we are in 2020, just at the very beginning, really, of the fire season, still at the beginning of the fire season, and you can see we'll probably shatter all records this year. Here's a little bit of footage just from what's happening in the area, in the various areas around California. It's pretty staggering because most of us in the presence of fire, we're leaving, we're evacuated, and so the actual fires are not something that we tend to see up close.
Yeah, we copy.
But here's some live video footage. See the ash in the air. Remember, these firefighters are fighting this typically right now over 100-degree temperatures.
We're making our way from the top of Carbaker. I need to re-up on water.
So the question is always, from an ecological standpoint or social standpoint, why is this year so much worse? Is it just a statistical anomaly? what's going on. And so what we have, and here are a couple of images, and I know you were just talking about being in the East Bay. Here's San Francisco, orange, and here you can see the Golden Gate Bridge. And
Okay.
let's take a look at the fire map for California right now. This is courtesy of the Los Angeles Times with data from CAL FIRE. And by the way, CAL FIRE is one of the most sophisticated weather and fire mapping sites you can go to. So it's pretty cool. And some of you may consider doing your paper or something, looking at the challenge of forest fires, and CAL FIRE will be one of the sites you'll go to. So you can see throughout the Intermountain and then west, the fires are all over the place. But this is California, currently with 43 active fires being battled at the same time. And these wavy lines show the areas of really bad air pollution. And you can see it covers essentially almost all of California. We escape a little bit here in Los Angeles, which is pretty lucky because it's the highest density of people. So there you have it. I mean, just absolutely staggering amount of fire that's happening. And really, there are three factors that are combining to make these fires so problematic. First
Okay.
of all,
Yeah.
There's
yeah.
something in the waiting room.
Oh, okay. Thank you. Okay. Participants now. Oh, yes, Chima. Thank you. It's weird that I don't see them pop up when I'm sharing screen. But I appreciate it if somebody lets me know when they see it, because I don't see it. Okay, there we go. So you can see these. So let's take a look at some of the factors here. Okay. So one of the things that's different this year than has been in previous years is that historically, somewhere in the vicinity of at least more than half, in some years 70 or 80% of fires are caused directly by humans, either making a mistake, such as one of the major fires here was started by an errant firework that was at a party, which is a pretty serious mistake, since for the most part the fireworks are not allowed to be used, and incredibly dry situation that we're in, it's pretty foolhardy. Or even something as simple as a spark coming off of a metal chain being dragged behind the trailer of a car or something like that. I mean, just when it's this dry, it doesn't take much to get it going. But then there's also arson, which is a serious problem globally, and in California as well. People start these fires either out of spite or anger, or to try and collect on insurance. And so this year, however, we've had an unusual number of lightning strikes hitting California. On one 24-hour period during about a week or so ago, during this heat dome, we had 10,000 lightning strikes in one day, which is pretty unusual. Of course, when I start the lecture, wouldn't you know, they'd start tree trimming. Hold on, let me shut the windows. There we go. I was giving an important presentation about a month or so ago to a funder that ended up supporting our work. And I'm sitting here in my study, and wouldn't you know, not only are they doing some work around the neighborhood doing landscaping, but they pull the chipper right underneath my window. And that's where you throw the whole... And even when you close the window, it was horrific. So I put it on mute, except when I was talking, and then it was pretty hilarious. So we had over 10,000 lightning strikes in about a 24-hour period, which is really, really unusual. And what was even more interesting from an ecological standpoint is these lightning strikes were the result of a combination of heat and the electrical imbalance. I mean, that's what causes lightning. The negatively charged forces or field is generated within the clouds typically, and then coming up from the earth are these positively charged streamers that they call it, and the two meet, and then the lightning exchanges. But typically, when there's lightning, there's also rain because lightning are caused in storm clouds. And so they tend to ameliorate one another. You have the lightning, but then you also have the rain falling. And any fires that start tend to be suppressed by the rain. And so the two kind of cancel each other out, not always. But what happened in California is we had what we call dry lightning or heat lightning. And we had no rain, not a single drop. So every time lightning was striking, it was hitting dry ground, extremely dry ground. Soil moisture is very, very low because of the heat spell. And the probabilities of creating fire or sustainable fire goes up because there's less moisture in the ground, there's less moisture in the leaves, and there's no rain falling in the form of precipitation to squelch any fires that might start. So it was an unfortunate combination. And as a result, we have an incredible number of fires that are raging. And you add to this the pandemic, it also makes it very, very difficult to manage human safety. Because what do you do in fires or storms or something like that? You evacuate people, and where do you put them? You put them in gymnasia at high schools. You put them in, in very high density settings. People who don't know each other, people who are outside their bubbles, if you will. And normally that's an inconvenience, but it's not a public health safety risk. And now we have this problem of what do you do with thousands of people that you're evacuating? Where do you put them? You can't put them all in a high school gymnasium. It's incredibly unsafe. So putting people in individual hotels, people opting to sleep in their cars as opposed to actually going into these buildings where people are at high density. So it's a very difficult and interesting challenge to try and ameliorate when you're trying to fight fires under these circumstances. Really high heat, very, very dry. So it's very tough on the firefighters. Water access is low. And then you have a pandemic that puts the evacuees at risk and, of course, puts the firefighters at risk. So is there anyone any of you folks who know anyone who's been evacuated or anyone whose own homes are at risk? No? Well,
Um,
that's
my my cousins in San Jose have gotten like evacuation warnings, but I don't think they've been evacuated yet.
Yep. Well, the warnings are helpful. And this morning, the LA Times, you could send them an email. The LA Times had an article about preparing for evacuation. What should you pack? What do you need to bring with you? Things like that. Because some things make sense, but some things you don't think of. Critical papers and things like that you need to have with you. Just because you might lose your normal modes of identification, cell phones might not work, all these kind of things. So, certain critical things you should bring with you, like a passport if you have one, a birth certificate, those kind of things, because you might have to rebuild your entire identity depending on what happens in the area around you. Anyone else have any experience being evacuated for fires or had fires around their house at some point in their life?
I think it was 2 years ago. I live like on Lime Ridge, which is an open space, so it's a bunch of like hills and like grass. There's a fire. They never figured out what started it, but it was like right by my house,
Ooh.
and we could like see the smoke and like the fires, and then they had to like bring an airplane that had to like drop like the fire retardant, and it fell on like a bunch of people's houses. So like houses and backyards are just like red.
Yes. It's pretty eerie to see. I last summer I was up north of Ojai, where you guys saw from the photographs on Tuesday, where I love to be. And there was a fire coming in, and in the Los Padres National Forest, there are still just a few ranches that are there. And you could see those ranches had been covered in fire retardant. So I don't know whether the government did that or whether the private homeowner hired a helicopter service to come in and drench, the immediate area around their house to give them some protection. It's sort of both. Thank goodness they got there with the fire retardant, but then it also is just a grisly scene because then you go by weeks later and they're trying to wash it off the house and stuff like that. But and people who live in those areas, you can fireproof your house to some degree, depending on what you produce, your roof, what you use as roofing materials, and then traditionally, what causes the houses to actually burn is not the things that land on the house; it's the embers that get sucked into the ventilation system of the house and actually start the fire from the inside. So you could actually you have to put screens and things like that to reduce the size of the passageways for air that create airflow into the house that bring the embers in. Those are the problems. I have a colleague who I went and looked at his house in Templeton, which is outside of Cambria, and he's up in the hills. It's a gorgeous house. He's used to be a professor of environmental studies at Cal Poly San Luis Obispo. And so he knew he was in a fire area. So the house is poured concrete, beautiful, these big sliding doors and metal roof. But then the critical piece was to create these sliders that can close the vents to keep the embers from going inside. And then the house is surrounded by trees, which puts them at risk. But the trees are in giant wheeled pots. And he has a little tractor. So if the fire comes close, he can pull the trees away from the house and create a safety zone. And then he's got thousands of gallons of buried water and a diesel-powered generator, so he can douse the house down with water and stuff like that. He said, look, if you're going to build in a dangerous area like that and you have a choice, then you should prepare for it. And so it's really a brilliant design, stone floors, poured slab concrete. So, the other problem that happens during fires is even when the fire doesn't actually get to your house, the heat is so strong that it damages, it blows the windows out, all kinds of things. And so if you prepare for that, you can build a house that's reasonably robust. If the fire comes right over the top, there's not a lot you can do. But again, most houses burn related to forest fires are ways away from the fire. It's the embers, which can go 2, 3, 4 miles, land in the house, and set it off. And someone else was going to make a comment. I thought I saw.
Oh yeah, that was
Emily.
me. If you remember the
You're
tea
muted.
fire in Santa Barbara, like in 2008 or something, way back in the day, that started right behind my house, and it almost burned my house down, but the winds changed at the last second.
Wow.
That was the first fire I was evacuated from. I've been evacuated from 3 different fires.
So you were really young then, what, 7 or something?
Yeah. I mean,
Scary.
Santa Barbara just tends to catch on fire all the time. So, yeah, because we had the tea fire, the Zaka fire, and the Jesusita fire, and all 3 of those I had to be evacuated from.
Yeah, it's an interesting way in which the hills are terraced, and it creates a sort of a ventway for the air to go. And
Especially in Montecito, like the
Montecito is just we
Yep.
drove through there because I like that old Route 192 is a wonderful way to connect from Ojai up to Solvang and other towns up there. And I love to go along 192, and it's just tragic to see those houses so damaged, and just damaged in odd ways in the way that fire happens. And then after the fire, because of the nature of the soils in California, you get mud flows. And almost as many homes in the last fire in Montecito were damaged from flowing mud as it was from fire. They managed to control much of the fire, but then the mud came. And that was the year that the PCH was closed. Oh gosh, it was terrible north of.
Yeah, that was bad. We actually had people like that we knew that died in the mudslides. They got swept away in it. Like, it was awful.
And and then the mud hardens. You don't even find the people. It's just,
Yeah.
it creates this adobe, and you can kind of drill through it once it's dry. But people don't realize how dangerous mud flows are because they move slowly compared to, say, floodwaters. And you have this sense that everything's unfolding in slow motion, and I can get a hold of it, but then you get trapped in it, and it's almost impossible to be rescued. It's just so, it's not funny, but we're sort of in this biblical phenomenon right now. We have fires, and it's a 17-year cicada, so we have the locusts, and then we have pestilence. We've got the corona virus pandemic right now, and you're living through some very interesting times. But also think about, and this is why I've taken this much time to get here, your lives are amazingly normal for all the things that are going on. Pacific Gas and Electric, Southern California Edison, the electricity has flowed, the natural gas has flowed. You need gas for your cars, you've still been able to get it. All these kind of infrastructure that has these layers of safety. We've had rolling blackouts, that kind of thing. But historically, when these kind of events happen, the infrastructure system really collapses and people become really super dependent on themselves, and have to have food stores and alternative energy supplies, or just live for days without electricity, all these kind of things. And there are people who are going through that right now. But given all the things that are happening in California and what could be happening in these high tension lines and stuff, our lives are, for the most part, amazingly normal. We're separated. We have to meet by television, by TV screen and stuff like that. But most of you have water flowing, electricity flowing, air conditioning, and so forth. So it is a testament to the redundancy and commitment to infrastructure. So as you grow into your civic roles as adults, it's something to think about, because when you pay your taxes at city and state and federal level, so much of it is spent on things you can't see. And so we tend, that's called, when we don't spend money, we call that deferred maintenance. In other words, we really should fix this power line, but it's still working and we won't worry about it. Nobody wants to raise that $1 billion. And so this is a time to think about, it's because of the redundancy and effort put into the infrastructure that we're able to get through things like this without it collapsing. And so supporting infrastructure is really, really expensive, but also really important, because we take it for granted until it's taken away. And right now we're living in times with all these things happening where, by all rights, these things shouldn't be working, but they are. And they're working because people have paid a lot of tax dollars, and a lot of people managing infrastructure have been working on this. So part of our Coyote study involves going onto land that's managed by Southern California Edison in order to get scat samples. And so Southern California Edison folks once a month take us out onto this property. And it's just wonderful to talk to these folks about all the work that they're doing, and you're underneath these giant power lines, and you just don't think about it. And they say, well, these go on for 100 miles to the major system, and in hot weather they can only transmit a certain percentage because the resistance goes up, so we have to use different lines. And it's just you think of the enormity of the task and the technical challenges that have to be overcome. It's pretty amazing. And speaking of coyotes and research, a number of you have kindly sent me emails saying that you would like to chat about research. So I thought what we would do is, when class ends at 9:15, anyone who can stay and wants to learn more about the Coyote project that we're doing and potentially be involved, remember there's lots of remote things you can do, as well as help us on site. We'll be joined by Dr. Weaver, Melinda Weaver, our postdoctoral fellow who leads the Coyote study in Culver City, and she'll join us at about 10 after 9, and we can have a little conversation about that at the end. Anyone who wants to stay, it'll just be a few minutes. Okay, talked about grading. Okay, let's make this a little bit smaller so I can see a little bit more of it. There we go. So we left off close to this area here, and I had the 3 readings I wanted you to get done by this week were the Pickett Urban Legends 2008 paper, the Urban Expansion paper by Sato 2011, Alberti's Chapter 1. And one of the things we were talking about here was the giant transformation, if you will, in the way that humans are now acquiring food. It wasn't that many generations ago that most people globally were involved in farming in some way, some form of subsistence. And with the domestication of plants and animals, we have been able to accelerate the amount of food that we produce to the point where we produce more food than we can eat, which means we need to store it. And then once you start doing that, of course, people have to stop, and they have to create granaries and controlled pastures for plants and animals. And then we talk about building walls to defend those resources. And now you have the start of cities. Even though it was 10,000 years ago, it's in fact the agricultural revolution that created this path we're on of excess food supply that then has to be defended and protected. So you build walls, you create towns and cities, but then you also free up a large proportion of your population that no longer is involved with farming, that can go on and do other things in a society, technical things like being a lawyer and a doctor and a tinsmith and all the kind of things that people do. But what that has done is pretty profoundly changed the way in which we acquire and consume food. I always ask my class this question, and I've yet to get more than sort of one or two people who've ever answered in the affirmative. Most people in the class consume at least some part of their protein from animals. We probably have some folks who are vegetarian, maybe someone who's vegan. But most of us do eat at least some portion of our diet is meat. How many of you have ever butchered an animal? How about cleaned a fish?
I have done both.
One, two. Okay, so that's technically butchering an animal, though it's not as messy as when you do a cow or a deer. Yeah, so this is the modern world. Your food comes from, in this case, in this country, really a pretty successful and trusted network that ends with you going to a store and acquiring a packet of meat, or more likely, especially if you're living on campus or at your age, going to a place where the food is prepared to the point where it's ready to be consumed. You either eat it there in-house in a restaurant, or you take it out in a bag or some kind of carrier and bring it home and eat it. And so you're removed from the growing, the feeding, the butchering, the managing, the cooking, and all of this kind of stuff. And that's not necessarily a bad thing, because there's a fixed amount of time in the day and you make choices about how to spend the day. And the ability, in fact, the idea of people eating in cafeterias, if we think about a global footprint, is potentially the most sustainable way of preparing and consuming food, because you're cooking it in larger amounts, which requires fewer individual fires, fewer individual people doing it. The overall footprint goes down. You have professionals who are managing food waste and things like that. Although in this country we don't do such a great job. We throw away about 30 to 40% of all the produce that we harvest, and almost 30% of all the prepared food gets thrown away. So, I mean, that's a huge ecological problem we need to deal with. By the way, and we're going to talk about this later in the semester, in the lab, we would have taken a tour. LMU is consistently ranked number 1 or 2 in the nation of universities with respect to recycling and managing our food wastes. We have an extraordinary program through Sodexo where almost every bit of food waste is sent through this giant churning machine, and then it's prepared and it's used, becomes fertilizer and things like that. It's an amazing excuse me, it's an amazing program, and we're very proud of that here at LMU. It's something we've invested in for the past 10 years to try and be a leader. But so the idea that you would go and get your food from a provider is not necessarily a bad decision. It just has to do with what are the decisions you make about what food you acquire, and what are the practices those companies are doing. So we had shown you this image of the 18,000 restaurants managed by the McDonald's Corporation, and that's the fast food industry is it's an interesting and conflicting food environment, because you think about how inexpensive the protein is to acquire. You could walk into a McDonald's restaurant and you can acquire 600-800 calories of meat in a bread, sometimes for as little as $2 or $3. I mean, that's an extraordinarily low cost with respect to acquiring protein. Now, those kinds of choices, because of the high salt and high fat and the other things that are put in those foods to make them more appealing to us and for them to be able to last a long period of time and have a longer shelf life and things like that, has all kinds of implications for our health. So we as we said in the last class, we've traded some of the historic nutritional crises that humans had: starvation, kwashiorkor, scurvy, the lack of vitamin D, and so forth, to the developed world's nutritional challenges of diabetes and obesity and metabolic syndrome, because we actually have transitioned from not being able to access enough of these limiting resources to being able to access too much. And our bodies, because of evolution, are trained to eat too much. We eat for the hunger to come, because most animals and most humans through most of history have gone through periods of starvation. And so the idea that your body rapidly acquires additional material stored in your adipose tissue is designed for you to be able to go up and down 20 or 30 pounds in the arc of a year because of the access to food. And so, as you probably have read, there's all kinds of metabolic studies going on now about the potential advantage of fasting in certain periods of time, because your body's sort of organized around the ability to fast, and however you want to call it, going on a diet, that's a form of fasting and so forth. Your body switches from the normal metabolic pathways to beta oxidation as a way of moving fats into the glycolytic chain. And so that causes your body to lose weight and that kind of thing. So it's a very interesting phenomenon that we've transitioned. And it's easy for us to dismiss fast food restaurants and say, well, they're terrible for you. Well, in one sense, yes. In another sense, if you think about literally the billions of meals that are served out of these restaurants on a daily basis, and the small percentage of people who become immediately sick from eating the food, it's a pretty extraordinary chain of events. Historically, being sick from what you ate was a pretty common thing to happen. And now, because of our food handling requirements and chemicals we can add to food that help to preserve it, we actually get much less in the way of bacterial and fungal infections from our food that we eat. And it comes from all over the world. So it's really an extraordinary network, one that needs to be tuned, one that needs to be addressed, one that needs to be approached with respect to food waste and things like that. But overall, it's a pretty extraordinary time to be alive. And you look at the cost, average cost per person to spend on food is going down. And the opportunities we have to have different kinds of food at different times of the year is actually going up. So it's pretty amazing. And so here are some statistics that we got. So at least 1 in 4 people eat some type of fast food every day. Americans consume about a third more packaged food than fresh food. Over 10 billion donuts are eaten in the United States every year. And about 1/5 of all of our meals are eaten in the car. Not a surprise. Millennials spend about half their food budget eating out, which is $6 billion annually. Eating out, $6 billion annually. It's just amazing. Americans spend 10% of their disposable income on fast food. So you can understand why the industry is growing like it is. And if you notice, so many fast food restaurants use the color schemes of red and yellow. McDonald's, Pizza Hut, Carl's, so forth. Those colors act as stimulants in your brain and make you hungrier. And if you go into fast food restaurants, if you notice the colors are bright, it's usually pretty noisy and the seating is hard. The idea there, because if a restaurant serves alcohol, they want you to stay a long time because booze is expensive. If they don't serve alcohol, they want you to eat fast, eat a lot, and get out. And so bright colors, hard seating, and noise makes you eat more, makes you eat fast, and makes you eat rapidly. So the average table time in a fast food restaurant is about 12 minutes, 15 minutes. You eat your food and you're done. And they can have rapid table turnover. You think about a fancy restaurant, with $14, $16 cocktails, that table might turn over only twice in an evening. But remember, the the two people that go there and have a few cocktails and dinner might spend $200 in one evening, and you're spending $6 when you go to fast food restaurants. You got to turn that table over fast. So the colors are different, the ambiance is different. One is slowing you down, one is speeding you up. You know, slow you down at a restaurant, you drink more, then you order a dessert, and then you order an after dinner drink, and you know, dun, 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 and on it goes. In a fast food restaurant, in a bag, on a tray, in and out. When we talk about urban ecology, we should set a couple of ground rules here. Let's talk about the idea of what we mean when we talk about urban. And so these two definitions come from one of the two major studies that have been done on urban ecology, long-term studies that have been done in the United States. One is in the Phoenix, Tempe area, that's called the Central Area Phoenix, or CAP study. The second is the BES, or Baltimore Ecosystem Study. Our team has worked very closely with that team. When you meet Dr. Michelle Romolini later this semester, she got her PhD working in the Baltimore Ecosystem Study. Dr. Melinda Weaver got her PhD working on the Central Area Phoenix Urban Ecology Study. So if you do urban ecology, in some ways, you're connected back to these projects in Baltimore or Phoenix. So when we talk about urban ecology, we have two meanings, where we use two kind of frames of reference. One is the so-called broad meaning of urban, and that the broad meaning of urban is this whole range of habitats and environments within the scope of the petroleum-based commuting network. We call this the urban mosaic, and it gives us the greatest variety of types. So note here, I mean, this is, thinking midterm, the definition is geographic, but the definition is also behavioral. So the definition, the broadest range of urban is the whole area that people take buses and trains and drive to get around to do their work and run their lives. So remember from the last class, we said that Los Angeles was at its highest density in 1875. Why? Because when you lived in Los Angeles in 1875, you had to walk back and forth to work. So where you lived and where you worked wasn't very far apart. But with the advent of public transportation, the automobile, the rapid expansion after the Second World War of the interstate system, it's not unusual for people to live 20, 30, 40, 50 or more miles away from work. And they simply take public transportation or a bus or a van or a car to get into work. And so that network is then connected by behavior. It's a little bit like a little mini Silk Road between where you live and where you work. You're transmitting culture and materials and using energy to go back and forth. And then we have the narrow meaning of urban. And the narrow meaning of urban, I think downtown, in the strict sense, refers to the densest built and paved component of the settled mosaic. So we have both the broad meaning of urban and the narrow meaning of urban. And we'll flip back and forth with those ideas, but you just need to understand the critical piece here is that urban has an idea of structural and geographic, but it also has an idea of human behavior. So urban is urban because of the way we behave and the way we cluster ourselves. And then, of course, we build buildings and infrastructure to support that. But if you're working downtown Los Angeles and you're living out in Agua Dulce, Agua Dulce itself seems pretty rural. Vasquez Rocks are there where they film all the westerns for TV and stuff like that. But you go down the 14 or come out of that Antelope Valley and boom, you're into Los Angeles. So when we think about urban, we have to capture those outlying towns because people are moving back and forth. And the impact, the ecological impact, we think about the city as a living metabolism. Those people who live farther distances actually use a significantly more petroleum metabolism to move back and forth between where they live and where they work. And you're also living in a period of time. Look, we have this forced experiment right now where we are working and living remotely from our connections. I think this will lead to a profound change coming out of COVID, where we will reevaluate how important it is for people to get in their vehicles or public transportation, whatever, and travel X number of miles. the carbon footprint in Los Angeles went down amazingly during quarantine. Now, the question is, can we actually have a social and economic ecosystem that doesn't collapse if we are all in these bubbles? But imagine if the bubbles are penetrable because we don't have COVID. It has everyone running universities quite nervous about the future of university learning. I happen to believe strongly that, especially in the ages that you are between 17 and 21 or 22, it's critically important to bring you guys together and learn all the skills that you need. Because one of the reasons we can do this back and forth is because we all know what it's like to be in the classroom together. So in fact, we're all behaving like we would if we were together. If we had never been together, we'd never enjoyed a shared campus, our identity would be quite different. And this is it's very much on the minds of urban ecologists and urban planners as we think about what does a post-pandemic world look like. Any comments on that? I'm always excited when somebody has something to say. Someone's lit up. Maybe not. How is urban ecology different from other sciences? And here we have an image from the 1984 earthquake. It's the one thing we've managed to escape so far with the pestilence and the plagues and everything else. So let's hope that we don't add an earthquake to this, because that could just really sever the final strands of resilience that we have in Los Angeles holding us together right now. But one of the reasons that urban ecology differs from other sciences is that we talked about being interdisciplinary and in fact transdisciplinary. But we also think of, and the way we do our science is to remind ourselves that urban systems are dynamic. And when we're measuring anything, it's really just a moment in time. It's like a calculus. It's an instantaneous sample. And we have to think about the fact that cities, ecosystems in general, but cities in particular, are constantly under change, and through a series of forces and drivers. So we have biogeophysical drivers, earth sciences, the biogeochemical cycles and things like that. They can be long-term, constant forces. We call those presses. And that example would be climate change. Now, granted, there's a huge anthropogenic cause to that, but the climate has changed a lot over millions of years, and that is something that is a constant force. We call that a press. Other things happen in the environment that happen very rapidly, and we call that a pulse. And this image here of an earthquake, that's a biogeophysical phenomenon. It may all be over in a matter of a few seconds or a minute, and it leaves it leaves me speechless. It leaves me it can have profound geographic changes in a very short period of time. Both of those forces leave profound changes, but think they work on different time scales. So a press is something that is kind of a constant force, and a pulse is something that happens quickly. So think climate change versus earthquake. Well, human socio-economic drivers are also critically important, and we call those anthropogenic because they're derived from humans. Genic comes from genesis, meaning the beginning, and anthro meaning human. So they have their source is human-driven. And so if we want to think of a human press, think of economic development. The history of Los Angeles, the economy as it shifted over the span of 200 or 300 years. And then we have something like a pulse. I know somebody mentioned being from Santa Barbara. Think of oil spills. And in 1969 or 1970, one of those 2 years, Santa Barbara had a huge oil spill. And that had profound impacts on the quality of the water, on the nature of the beaches, and then and that was caused by humans. And as a response, it spawned a whole series of things, like the Coastal Protection Acts in California, Coastal Access Acts. We woke up to a huge problem with respect to oil extraction. And California and other states and the federal government got real serious real quickly about managing these potential risks.
Dr. Strauss.
And this is this was the Northridge quake.
Dr. Strauss.
Yeah.
Wasn't there an oil spill in Santa Barbara like a few years back, more
Yes.
recently, like a big one? Yeah.
It wasn't as big as the '69, but yes, it was. It was a pretty serious spill. The difference in this spill is that we had the booms and the equipment and the helicopters and everything that were able to respond. And we also learned things. Typically, oil spills have occurred in really cold water, like Prince William Sound in Alaska, the North Sea off the coast of England. These are miserable places to try and extract oil. But our world has a voracious appetite, and we're going to talk about world economy and oil next week. A voracious appetite for oil, so we go where it is. And underneath the North Sea and underneath the shale off the coast of Alaska, you have just these incredible oil reserves and oil that is really high quality. And so we put these oil rigs out there, and it's just, you watch the storms that happen and the sort of courage these people have to have in order to work on these oil rigs. I mean, they're extremely highly paid to do it. It's very, very risky work, and the mortality and morbidity rates are very high out there. But we use millions and millions of barrels a day of oil, and so occasionally they topple over or they just blow up, and oh God, it's terrible. And so most of what we had learned about oil spills were in cold water. And as you know, as you cool something down, the rate of chemical reactions slow down. And so the oil turns into these globs, and it comes ashore and it covers animals, and it's terrible. You guys were alive for a more recent oil spill that happened in the Gulf Coast, which is warm water. And there, the oil was different to manage. And when it was all said and done, about a third of the oil that spilled could not be accounted for by the traditional means that we manage cold water oil spills, which is measure what washed up, what did we skim off, what got flared off and burned, and so forth. But what happened in the warm environments is much higher proportion evaporated, and there were bacteria in the warm water that ate the oil that weren't in cold water. So just amazing. So the actual long-term implications of the spill in the Gulf was much less than what happened in Prince William Sound in Alaska 10 years before that. So it's really interesting what we're learning about how to manage these presses and pulses that happen in part of this human condition. Because it's easy, not easy, but it's straightforward and very true for us to say we need to wean off and reduce our dependence on oil. That is absolutely true. It is harder to shift an economy that is that dependent on petroleum products as we are. I mean, if you think about it, we still get about half of our electricity in the United States from coal. That's been an industry that we've talked about retiring for 50 years. And China is a voracious consumer of coal because we tend to use the carbon-based products that are easiest for us to get. And throughout the history of technology, our carbon-based sources went from being wood, which doesn't have a very high density, to coal, which has a reasonably high density, to oil, which has a super high density. And you can put 10 gallons of gasoline in a car and go 600 miles moving a 2,500 pound object. That's an extraordinary energy density that's very hard to replicate. Think of how much heavier an electric car has to be to carry all those batteries. We're in a challenge right now because we're trying to get Californians, and we actually give significant tax benefits to people to switch to electric cars. But one of the challenges we're having this summer with the high heat is there are now thousands of cars that are plugging into the electrical grid to be recharged. And that adds enormous burden to the electrical grid. Right now, if everybody switched to an electrical car, the electrical grid would collapse because of the demand that it has. Also, we're challenged that half of our electricity comes from coal. So when we talk about an electric car being zero emissions, it's not. It's remote emissions. The emissions are occurring at the time where the transformation is happening of the petroleum product that's being used to produce the electricity that charges the batteries. And so in cities, it makes sense to have electric cars because the emissions happen in areas where where fewer people live. And so the implications, respiratory implications, are more favorable. But there's no free lunch here. I mean, the size of we're building solar panels and wind turbines as fast as we can, and that's helpful. But the amount of electricity required to charge the batteries to run a car is very, very significant. Even at a 240 house line, it takes hours and hours to transmit that much electricity into the batteries to charge them up, because it's not unusual for an electric car to weigh 5,000 pounds, which is more than a truck, because of the weight of the batteries. So it's an interesting challenge. All these things fit into this mosaic of solutions to resilience. So another aspect that we need to consider, and it's probably the last thing we'll do today before we do the signups, I haven't forgotten. There's still a chance I'll forget to do the signups, but you're all primed to poke the bear when I forget, is to talk a little bit about the idea of ecosystem services. So one of the readings that we'll do later in the semester has to do with ecosystem services. This is from Daly's 1997 book called Societal Dependence on Natural Ecosystems from Island Press. By the way, Island Press is a nonprofit extension of Harvard's Belknap Press, Harvard University's Belknap Press, and they have this incredible collection of books on environmental science and environmental activism and the history of ecology. It's just, if you're interested in this and you're looking for books to acquire for yourself or to give as gifts or something, Island Press is really an extraordinary. They're one of the few presses that's nonprofit. So they do their best to keep the cost of their products down, and some of the best environmental writers in the world write for Island Press. So ecosystem services, what do we mean by that? Well, let's use the Boyd and Bonzoff definition from Ecological Economics, a 2007 paper. Ecosystem services are the components of nature directly enjoyed, consumed, or used to yield human well-being. We're going to talk about the problem with that definition, hopefully today, but if not, on Tuesday. And here's a list from Daly's book of what ecosystems do for us, healthy ecosystems do for us. They purify the air and water that we drink and bathe in. They mitigate droughts and floods. Nature generates and preserves soil and renews fertility. Nature detoxifies and decomposes waste. Pollination of crops and vegetation, the dispersal of seeds, the cycling and movement of nutrients, and the control of the vast majority of agricultural pests. All these happen naturally in healthy ecosystems. Now, in ecosystems that are disturbed, or in areas where people live at high densities that exceed the ecosystem services, then each of these systems has to be supplemented with technology. But it's important to remember that the technology is much, much more expensive and labor intensive. So when Los Angeles 500 years ago was occupied primarily by members of the Gabrielino indigenous peoples, the purification of air and water could happen naturally. But now, because the Los Angeles basin has 14 million people, we have to have 5 water treatment facilities, the largest being Hyperion, which is only a couple of miles from LMU, that handles 400 million gallons of water a day. That's all the water that you poop in, because the storm water is diverted a different direction. So this is all just the wastewater. So 14 million Angelinos contributing their human waste to the system is managed by Hyperion, because it exceeds the ability of nature to do that task at that density. And since we've destroyed approximately 93 or 94% of all the natural wetlands, which is our water repository. We even have less of those ecosystem services. So that's just one example. So mitigating droughts and floods, how do we do that with technology? We channelize the rivers and we build berms and levees and things like that. But remember, those are always more expensive when we end up doing that as a solution. Pollination of crops and natural vegetation. So, how are most of our farm crops pollinated now?
Is it by technology that we use?
It's a form of technology, but it still uses nature. It's an interesting challenge. We're actually in a bit of a crisis right now because of something called colony collapse. Which
don't we have like beehives and
yes,
like that actually go
exactly.
to farms?
Billions of bees are transported in hives on trucks around the country all year long and rotated to different crops so that they can pollinate.
It's really cool.
It is amazingly cool. It is amazingly cool. But we're running out of bees because of climate change and all kinds of challenges. So we have lots of native bees who would do that work, but there's not enough of them. So we transport European honeybees, and in those white containers, each one of those containers has about 50 to 100,000 bees. And you see the trucks moving around that'll have 500 million bees in them, and they set them up for a certain amount of time, depending on the time of year. When they have to do the almonds or when they have to do the strawberries, all these kind of things, and then they move them on. And it has been an industry that it's biblical. It's as old as the Bible. And it's a multi-billion-dollar industry. But it's incredibly fragile and dependent on these bees, because we don't think about the fact if you don't pollinate the crops, then you don't complete the life cycle. Now, some things we can do through vegetative growth, like strawberries, they don't have to be pollinated every year. And in the wine industry, we graft one group of wine to the next, or to the fruit industry, some of the fruit industry. But for the most part, you got to have pollination, or you don't produce the fruits.
So they let the bees go, and then do they recapture them after they're done with the pollination?
Yes.
Or they just,
Oh,
how
yeah.
do they do that?
The bees come back to the hive on their own every night.
Oh,
That's where they sleep at night. And when they come in at night, you can close it and take it out.
okay.
Yeah, it's pretty cool. Our lab back in New England, we studied bees because bees have a very sophisticated non-human language. In fact, Nobel Prize was awarded to Carl von Frisch for the deciphering of the honeybee dance language. Bees can count. Bees have a very highly sophisticated geographic understanding, and they have to transmit all this information to their sisters. They have haplodiploidy reproductive system, which is really amazing. There are very few males in bee society. So when you see a hive filled with 50,000 individuals, probably 99% are female. Same with the ant colony, because the females are more closely related to each other than they are to their brothers. In fact, they're more closely related to the sisters than they are to their own offspring through an unusual genetic system called haplodiploidy. So it's fascinating ecology, and honeybees have been central to the success of humanity going all the way back to the Romans and the Greeks, and before that, to African communities. Yeah. Honey, the first alcoholic beverage. Does anybody know what it's called? Looks like if someone Aiden's going to make a guess.
We had to read a book about it in high school. Was it mead?
Yes, indeed. Honey wine. Mead made from honey. Yep. You read about it in Beowulf. After he slays Grendel, they all drink mead. Sure, why not? We have time to start this, and then we'll come back to it. So as a result, when we frame research questions in urban ecology, and this is really important, I would ask you, if you're smart about it, you can download the PowerPoint. I would download it. I would print this page out and tape it into your notebook. Because when we do science in urban ecology, we frame all of our questions around this conceptual framework provided by the National Science Foundation. So if you're a scientist doing research in the United States, you really can't do research without external funding. You need resources. And so if you're doing medical research, your primary source of federal funding comes from something called the NIH, which is the National Institutes of Health. If you're doing research that isn't medical directly, if it's ecology or physiology or animal behavior or something like that, then chances are your research funds come from the National Science Foundation, or the NSF. And so in order to get that funding, you have to compete. And typically, I've had, I think, 11 NSF grants in my career. And typically, when I submit a grant, my chance of getting funded will be 1 out of 15, 1 out of 20. So they fund 5 to 8%. So it's fiercely competitive. And you often have to submit the grants, which are over 100 pages by the time you get them all done. I mean, it's an incredible amount of work. We have 2 major ones going out this October, proposals. When they dictate how they want the science done, you listen, because if you don't follow the dictation or you don't respond to the request for proposal appropriately, you just won't get funded. And so that has an effect of increasing the quality and the nature of the science that's done. So a little over 10 years ago, the National Science Foundation produced their 10-year plan for doing ecological research, so-called decadal research for their LTERs, which are long-term ecological research sites. And I think I told you about one, Baltimore and Phoenix, but there are 30 sites across the country, but only 2 of them are urban. And so they say, look, when you're doing ecological research, it's traditional for you to understand how biological systems are structured. That's what we do as biologists, whether we're studying at the molecular level or at the biospheric level. We want to understand how something is structured. And we also want to understand how it functions. So that's the study of biology. How is it structured? How does it function? How do cells work? How do ecosystems work? And so forth. But if you're going to study an integrated and interdisciplinary system, then you also need to understand the human side. And the human side is measured in the outcomes. And our outcomes are dependent on our understanding, our cognition, our behavior, and our institutions. And those institutions and behaviors create long and short-term impacts, presses and pulses, what we call our external drivers, onto the structure and function of ecosystems. And the feedback loop here are the ecosystem services. So what is it that we're doing that impact the systems, ecosystem services that we depend on as humans to survive? And what are we doing in the form of presses and pulses that impact the environmental communities, ecological communities that we're studying? And so this becomes a network and a series of questions that you can build. So as you think about in the lab, for instance, the independent projects that you may want to do, or you think about your term paper in urban ecology, this is a guiding framework for you to move forward. And we'll come back to this with our first conversation on next Tuesday, because it's so central to what we're doing. Okay. All right, go away. Now you're going to go away. Let's talk about our group presentations. Let me bring up, is that it? Oh. Come on. I have too many things on my screen. Yes, there we go. So you all received this in the mail, I hope. And what I'd like to try and do is, at the very least, get the first group set up, 2 groups of 2 each. Because throughout the semester, we have 5 presentations: dynamic cities, forces and drivers, urban wildlife, urban forests, and environmental justice. And hopefully these dates will remain robust unless something happens at the institution. You know, I don't think there'll be a problem, but the date should be fine. And then, what you're going to do is develop a 30-minute or so presentation that you will deliver jointly with 2 or maximum of 3 people. I think it's better with 2, but I've already had a request for somebody who wants to have 3, and it's like, but we have 5 and we have 2 groups in each, so we have 20. So that works out pretty perfectly for have 2 people in each group. So do we have volunteers for at least the first presentation on the 24th?
I'm willing to go.
Emily, okay.
Yep.
I'm going to put you in here. Do. Look at
Also,
that.
me and Leela.
Okay. Kelsey, you want to work? Okay.
Yes.
And I'm sorry, Kelsey, who was the person you wanted to work with?
Leela.
Okay. L-I-E or L-E-I?
L-E-I.
Okay. And Emily, is there someone that's going to work with you maybe?
I don't know, maybe.
Who wants to work with our Danish representative who's got a 9-hour difference?
I would.
Cameron?
Sounds good.
All right. Okay. So the way we normally do this, towards the end of class, I just put it down on the table and walk away, and the pencils are flying. And so this is interesting. We have to do this. Okay, while we're at it, how about October 8th, Forces and Drivers? Who'd like to potentially do that?
I could do it.
Janelle? Okay, thank you. And sorry if I spell your name wrong. I'll go back and fix these at the end of class. Who'd like to work with Janelle? Who would be lucky enough to work with Janelle? Let's market it that way. Who gets to have it done before the first week of October is done, before it gets busy? We could ask Janelle to pick somebody. Oh. See, this is terrible because we're not in the same room. I don't want to just assign them.
So, sorry. I have
That's
a
okay.
question about how the presentations will work.
So, in the case, let's say, of Dynamic Cities, Emily and Cameron will get together and create a 30-minute presentation that they will then do together. It might be a PowerPoint. It might have multimedia. You might hand us a reading to do or something like that. You might choose one of the readings that you've already been assigned, and you do an analysis of it. When you go on to the Brightspace, you'll see that there's lots of readings there. You can choose from any of them if you want, or suggest your own, and do a presentation.
So I mean, do we have to present on a very broad presentation on the whole scope of that topic, or can we narrow in on a very specific?
Oh, I hope you'll narrow in on something that we wouldn't otherwise have time to talk about. Yes.
Can I volunteer for urban wildlife?
Of course.
We're going to get a presentation on pigeons.
Excellent. Aiden, right?
Yes.
Mrs. Strauss.
Don't forget to look up Charles Darwin, who's one of the first pigeon fanciers to make a science out of it. It's wonderful. Some of his earliest ideas came from pigeons. Yes, Taylor?
Could Vin, Birdie, and I also do urban wildlife?
Okay.
I'll sign up with Aiden.
Wait, who just agreed to sign up with Aiden?
Rebecca.
Okay. And Taylor, who did you want to have work with you on urban wildlife?
Could I have Vin, Birdie?
And Vin?
Yes, please.
Is that V-I-N-H?
Yeah.
Okay. Now, somebody needs to and will be delighted to work with Janelle. Hey, there's Dr. Weaver joining us. Hey, Melinda.
Hi.
All right.
I have to get back to another meeting in a few minutes, but
okay. So
I was jumping in to say hi.
Oh, well, thank you, because we want to talk about coyotes. So what we're going to do, this is as far as we're going to get today, but we are all set for the 24th. So let's stop there. I'm going to save this. We'll return to it on Tuesday. Think about it some more. Form your groups maybe over the weekend. Um, and so what I'll do now is I'll conclude the formal part of the course. I'll see some of you in a few hours in the lab. And I know that there were some of you who were interested in research. And for anyone interested in the coyote research, please stay on. And we're going to spend about 5 minutes or so talking about coyotes and what are the projects that can be done if you want to join us. And that can actually be a project that you do also in the lab. It can be your project that you do in the lab. So anyone who would either like to do it as independent study or as part of the lab project, just stay on and chat with Dr. Weaver. So Melinda Weaver is from Arizona State University, where she got her PhD, and she has a very broad range of biological talents. And she's serving as the head of our Culver City Coyote Study. She's also developing curriculum. She's been involved in a lot of public outreach. She's an excellent writer, and we're delighted to have her on board with us at the center. So you want to talk a little bit about your coyote study and what students could do?
Yeah, so I basically have right now, because we're not out in the field, I have one big thing that you can do. And that is that in order to figure out where the coyotes are going, I think it's 28 or 28 cameras, I think, out right now throughout Culver City. And these cameras capture basically what the coyotes are doing throughout Culver City. So I have them stationed at parks and open like green spaces, and then sort of at some like dead end areas along the creek where I think that they're coming into the town. So the reason that we were contracted to do this work is that the coyotes have I don't know if you know what Culver City looks like, but it's basically sort of kind of wrapped around this area called the Baldwin Hills, and that's where the Inglewood oil fields are. So there's it's like 100 acres or something like that, maybe even more than that. It's a bunch of acres of basically land that nobody's allowed to go on. So except the oil field people. So coyotes live there, and they're presumably very successful there, but they've started to encroach into Culver City. And that brings them into conflict with humans in the form of cat predation. So they have, over the last like 2.5 years, I think we're at 85 cats or something like that. Maybe we're closer to 90 now. I lost track recently. And so the people of Culver City are concerned. So I've been trying to figure out their movement patterns and their diet. And the diet comes in the form of studying their poop, which I don't really have a need for right now. I already have a student on that, and it's kind of hard to do from your home. But I am also monitoring their movement patterns. I'm looking to see where they're going, what they're doing, what kind of animals they're interacting with, if they're affecting, the prey distribution, like if they're affecting where the cats go, or possums, skunks, raccoons, squirrels, rabbits. Those are the things I catch on my cameras. And so I need students to help me analyze those photos. So basically every week I go out and I collect, what do you think, Rebecca, how many photos do you think I have a week? 10,000?
50,000?
Probably
100,000?
I probably collect about 20,000 a week, I bet, because that one camera 17 alone gets 7,000 photos a week.
Yeah.
So I bet I get 20 to 25,000 photos a week.
Yeah.
It's a frightening number. That's why we don't edit them.
Yeah, exactly. And a lot of them are just like vegetation moving, or, whatever, people walking by. But I get a lot of cool ones as well. Yeah, those aren't mine though.
No, but it's just a cool picture. I just grabbed one as quickly
as I could. Those are the Long Beach Coyotes. The Culver City Coyotes are much more handsome and dynamic. So I capture them sort of running through basically just sort of running through areas. I do have some pictures of them hunting. I have some pictures of them with their prey. I have a lot of pictures like that. Yeah, like that, of raccoons walking through, of cats walking through, of coyotes walking through. Oh my God, that's what you were doing?
You're talking to Duncan?
Oh no. Yeah, Duncan is very excited about this freaking tennis, like gross, broken up tennis ball all of a sudden. So I monitor where they're going, and there's a program that sorts through it. Rebecca's doing it for me right now. Rebecca's in charge of this project. But this is she'd be the one training you how to do everything. But there's a program, and you basically just go through and sort the photos that we get into files, and we keep all the cool animal ones. And then we're going to look at where coyotes go, what animals they're interacting with, and how they're affecting other animals. So we'll keep track of if they seem to, do something different, if the raccoons behave differently when coyotes are around, if the cats aren't present in the places where the coyotes are. So like I said, I have about 28 sites. I collect cards every week, and I'm looking for students to help me go through the photos. So my data collection is really, we can't be out tracking the coyotes. That's just too difficult. So this is the next best thing. And the people who are looking at the cameras get to see where the coyotes going and what are they doing when they get there. So it's a pretty fun job, I think.
And it's also worth noting that one of the advantages of getting so many photographs is you actually have then a very large sample size, and the fact that when coyotes are there and when they're not there, negative data. There's some very sophisticated analytics you can apply to these camera arrays that you get, and you actually can ask some very sophisticated questions about the population structure, both the temporal use of areas, the timing, the spatial use. That picture I showed you of the 3 juvenile coyotes, those weren't the only pictures of that family. We got the pictures of when the mother was pregnant, when they first emerged from the den, as they grew up. They went from 4 to 3 and then to 2. So you can actually look at either dispersal or, depending on the age, you can see mortality. So you actually pick up an enormous amount of information. And so not only are we asking you to work with us to sort, but you can then peel off a section and say, I'm interested in looking at potential diseases, or I'm interested in looking at growth rates, and you can do allometry and some pretty interesting stuff as student projects. So what happens is it becomes this resource database of imagery that we know the time, the location, the exact time, the exact location of every image, and you begin to put together a mosaic of behavior. And we've gotten we, meaning collectively the discipline, has gotten pretty competent. And in fact, we have another graduate student who's joining us, who you'll meet later in the semester, Kate Weiss, who's actually basically going to get her PhD, doing an even larger array of cameras to look at overall population structure, something we call occupancy modeling. And at the very most fundamental, it's a biodiversity study: who's there and who isn't. But it spools up from there using sophisticated analytics and mathematical models to ask some pretty important things about the nature of urban ecology. So it's so different. I've been studying coyotes now for almost 30 years. And, the models before, you put a radio transmitter on and you literally follow them around with an antenna for hours and hours and hours. And now all those data go to a satellite, remote cameras gather the data. What it allows is somebody like Dr. Weaver to gather data on so many more animals in a shorter period of time. It's just an amazing time. We still put radio transmitters on, and we will be doing that with our coyotes in Culver City. And then we'll have, assuming you're back at campus in the spring, you'll be able to if you want to work with us, you'll be able to take an antenna out and follow them, figure out exactly where they are. But these photographs will actually become the primary way in which we understand their movement, with the goal of helping the residents of Culver City manage the conflict, because we've had 80-some cats that have been killed.
Does anybody have any questions? Because I have to go back to this
muted.
other meeting I was in.
You're muted, Melinda.
Oh.
There you go.
I'm not. No, I'm not. Can you hear me?
Yes.
I was just saying I have to go to my other meeting. So does anybody have any questions or anything for me?
And I'll answer some questions. And then what I'll do is after people have heard this, I'll ask them to send me an email and tell me if coyotes are of interest. And then we'll go from there. We'll set up a meeting. And again, think about it as an independent study, but also think about it as your independent project for the lab. How many of you, by show of hands, are also in the lab? Okay. So this would be a very cool project to do. It is going to be one of the projects in the lab because we need the help, and it's one of the remote things we can do. So, all right. Thanks, Melinda.
Okay. Thank you, guys. Nice to meet you.
So any questions that I can answer about the coyotes? And then in the spring, assuming we get back. Now, also for those of you who are on or near campus, there are some other potential opportunities for you to join us in person for things that we're doing. We're trying to get permission from the university to allow that to happen. So we have to go and find scat samples. We have to go and find dens, all these kind of things. And I think it's very safe to do because we're working outside. People have masks on. You can easily keep 6-foot distancing. It's certainly safer than going out to eat in a, in a restaurant or something. And we've never stopped doing it ever since the pandemic because our work is considered public health. So we've been able to keep going, which is great. And we've been psyched to have Rebecca working with us. She has become the goddess of coyote imagery. She's going to be so sick of it. I think in the end she'll probably smash a camera just to celebrate.
Yeah, it's really fun. So please help anyone. So there's so many. There's so many photographs.
So all we're doing is basically looking at the pictures. Do we have to write a report on it, or how do we get that information across of what we see in those pictures?
So they get sorted, and then you're actually gathering the important data from each image. So was there 1 coyote, 2 coyotes, 3 coyotes, what other animal, and so forth, and they get sorted in that way, and then you're part of the group that does the analysis. Like you might be interested, how many times are coyotes spotted with other species nearby? How is it an interspecies interaction? Boom. Okay, so you might write up that report. So does that vary by time? Does it vary by season? Does it vary by weather patterns? You can ask all kinds of really interesting questions, and boom, there's your lab report. There's your semester lab report. Or that's a poster that you would do for the undergraduate research conference that we do in the spring. Some years we have, 12, 15 posters. Now you're going to hear about other projects too that we're doing. We're doing social network analysis and things like that, and we'll get Dr. Romolini to come and join us next week and talk about that.
So I'm still interested in researching either way, but what are the outcomes of research if I'm not in Urban Eco Lab? Is the objective that I'm able to put it on a resume and have another thing in my
3
belt?
things. As all Jesuit answers have 3 parts, as you know. 1, you put it on your resume. 2, you ask the old professor, graybeard professor, for a letter of recommendation, and it comes from the old graybeard professor, which is usually useful. And then 3, you do a poster that goes into the undergraduate research conference, and you become an author on which is the most important if we get to that point. And even if you graduate, you're still part of our team. We get to the point you become an author on a paper. And for those of you who are bio majors and you're thinking about this, and you're thinking about going into doctoral programs to become a biologist, the traditional trajectory is to get your undergraduate degree, then your master's degree, and then your PhD. If you do enough work as an undergraduate, you can skip the master's degree altogether. Save yourself $100,000. Because when you get to a doctoral program, those are paid for by the institution. You usually get a teaching fellowship and a tuition waiver. So all 7 years of my doctoral program at Tufts were paid for because I taught for the institution. And because I had done a significant amount of work before I got to graduate school, I was admitted directly into the doctoral program and skipped the master's program. And that's really, people don't think about that, but that's really important, especially you and your parents, your caregivers, however you're financially sorting this mess out to get through your higher education. I always tell students, try to figure out a way to excise the whole master's program, throw it to the side, and go right to the terminal degree. Unless your terminal degree is a master's degree, which is fine. There are a lot of great careers for which master's is the terminal degree, but more and more the doctoral degree, even in things like physical therapy, occupational therapy, it's doctoral programs. And so you want to skip over the master's if you can and save that money. And you do that, as Aidan pointed out, by getting a strong resume of research, hopefully a publication, and definitely presenting your posters at undergraduate research conferences. Some of you may graduate with 2 or 3 posters. That's fantastic. Now you're talking, and when you put in your personal statement for things, it's got a research profile. You're saying, well, I volunteered or volunteered. Yeah, I did original research on occupancy modeling in Coyote Ecology, and we use this mathematical model. It's like, boom, we used an R-based program to understand. I mean, that's what you would normally do. That's the advantage of one of the reasons you chose LMU instead of going to a big university. Because if I was at an R1 university, like Arizona State, or I was offered a position at West Virginia, then these conversations would all be happening with graduate students. But at LMU, we don't have traditional graduate programs. And so you guys get to do that work. So you guys get to do work, and guys is gender neutral for me, by the way. So everyone's a guy. I suppose it's just everyone should be a gal, but or a GLA. Maybe we can put the two together. Everyone's a GLA. And so all the GLAs on my team, for the most part, are undergraduates, except for the grad students I import. And we always have a grad student on hand. We've had one from UC Irvine. We've had one from UC LA, and now we have Kate Weiss from Arizona State. Because I think it's really important for you to be around PhD students, because they're only a couple years older than you. And of course, their world is different than someone who's in his 60s. And so it just makes it for a healthy environment. But it does mean at a place like LMU, or predominantly undergraduate institutions like most of the Jesuit universities are, that as undergraduates you get involved with this work that's really at the graduate level and may help you jump over a master's program. So, all right, so send me a note if this is what you're interested in, and we will see you guys.
Dr. Strauss?
Yep.
Just a question. For our meeting tomorrow, what Zoom link should I use?
I got to send it to you. We'll probably use the one we used today. Yeah, let's just use that one, because that Zoom link is live for the semester. And 11 o'clock my time, right?
Yep. Sounds good.
And are you going to come to lab today?
Yes.
Okay, but what we'll talk about tomorrow is how to figure around that, because it's going to be.
Fine. It's
going to be 10:30 p.m. your time, right?
Yeah. Yeah.
I'm so asleep by then. Oh golly! All righty, guys, be well.
All right.
Dr. Strauss, I have a question about presentations. Just about the presentation, since Leela and I are going for the first ones to go. So are we allowed to put in maybe a small video in there?
Absolutely, that makes it much better. Yes. Okay.
And also
shoot your own video or something. Do crazy stuff. Do cool stuff.
Okay, cool.
Oh yeah, you should have fun with this.
Okay, cool. So it's pretty free for all. We don't really have to follow a certain not necessarily guideline, but
most students do. And I'll talk about it more on Tuesday. What you want to do is you want to present some information, present some interesting questions, and force your colleagues to answer questions. And I will force them to.
Right.
Yes. Bye, guys.